Hi all. So today's video we will discuss about the detailed explanation of linked list. I think you're already aware about the importance of linked list. Like any other data structures, linked list also very popular in our industry because we can solve lot of problem with the help of linked list. So first we will discuss about why the linked list evolved. The reason is that in the previously we used the array, right? In the C and other languages, we definitely want to define the size of the array, but that is not properly work in all case, right? So that is the reason we are introduce the linked list. I will tell you. So normally, in the case of array, what we do, we are allocating a specific set of memory space. Okay, specific set of memory space in the computer memory for the array. So actually, I implemented at the end of the now we are pushing the data to the array, but at the end, what we do, we need to stop, right? So after that, the next memory location, it will be store another data structure. So after that, I need to implement one more item to the data array. It is not possible in the case of C and C++. So that is the one issue with the array. That means the array need the continuous memory space. So to overcome how we can use the different memory space with the connected all these things. So that is the reason the linked list implemented. So the linked list concept means I will tell you. We need to know how the list linked list. So in the images you can see here, for example, yes, this one. So this is the concept of linked list. So here what we do, I will take the copy of this one. Okay. So here we can see that this is our linked list. So what we do normally we are pointing to the data. Normally we push the data to this one. After that we allocate a small memory space for allocating the memory of the next element. So here we are using as a reference. So in this location it is pointing to the B. That means the memory address of B is storing here. So after this A, it will pointing to that memory location and access the B element. And here we are storing the memory address of C, and once B is accessed, it will be pointing to C, then so on. And at the end, we will pointing to a null. That means the end of that linked list. So that is the whole idea about the linked list. Then, what are the applications of linked list? Before that, I will tell you there are three type of linked list implementation: singly linked list, and doubly linked list, and the circular linked list. These are the three categories that we will discuss in the next videos also. And next part, the application. Like application is very important. Otherwise, what we do, right? For example, you need to implement a stack queue concept. So that with the help of this linked list. And next one is we want to allocate more item without concerning this range factor. So that time also we can use the linked list. So and also we need to, for example, we need to add the element at the first position, no first position of the memory without the time complexity. Okay, but in the case of array, what we do normally the array like this one, right? So if I delete the item from this position, I need to move. I need to insert a new item to this position. What will do? I need to rotate this item to here and swap this item to here. So this will so on at the end of the list. So that is because of n time will take. But the linked list, it is a simple problem to assign the value to the new node and connect it to the position of friend, then assign it to head. That means only constant amount of time this issue we can solve. So that is the reason we are preferring in some cases linked list. I think you get all idea. Then we can move on the next part. The next part means we need to analyze the coding. So that we can do. So you can see here. So the linked list is classified into three types. So first one is simply linked list. The simply linked list implementation in Python. So I will copy this one and I will paste. We need to, for the simplification, I will paste. So what we do normally, in the first position you can see head equal to, this is the creation of linked list. This step we need to use for the linked list creation. So this lines is used for linked list creation. So head equal to node of 10. So this is pointing to the node of 10 means it is for calling this class and assign to self dot key equal to node and self dot next equal to none. So and next one also node equal to, that means this node equal to 10, how it works I will tell you. For example, node equal to none. So it will call it the function and create the node 10 and this position is none and 20 none and next one is 30 none. Okay, and this is happening in the case of these calling. And one more thing, first one head equal to node of 10, that means this one is set to as head, so that is the first point. And next line you can see here head dot next equal to node of 20, head dot next equal to node of 30. So that time it will be mapping to here and this none will be removing. This none will remove and what will do? It will be assign the address, for example 0010000. So this is the memory address of 20. And the next one is head dot and next. So that time it will be assigned to this 30. So that time also this none will be changing to memory address of 0000101. So that is the address of this 30. So this is the working of the first creation of a singly linked list. I think hope you all clear about that. And this time, so yeah, so when you execute this one, we didn't get the output because we just created the node, but we didn't write the function to traverse and print the statement. So that we need to execute in the next line. So that I will tell you how this works. We need to traversing a linked list in Python and print it. So that is our aim. Okay. So what we do, so here you can see that head equal to, this is already we creating 20, 30. So this after this column, first it will call to this line, then the node of 20, this will calling to this line again, and node of 30, this also calling to this line. So after this, it will be created a linked list. So that is like this. So these are the creation of, after the creation of linked list, the linked list like this, and this is pointing to the null at the end. Okay, you got it clear, right? So the next one, we need to iterate those items into one by one. So that is the reason we are calling this function print item of head. We are passing the linked list as parameter. Then we are assigned to a variable current. Current is a variable, so it is pointing to the first element. And here the current equal to head, while current not equal to none. That means the current is traversing until at the end. End means it is none. So that is the reason. It is not equal to none until it is not equal to none. It will be process and print where current equal to current dot key. We need to data. So that is the reason. and current equal to current dot next. This loop will iterate at the end. So here you can see it will be none, pointing to the none. So at the end it will be pointing to none, it will be stop. So that is the reason it is traversing like this. So when I execute this one, I get 10, 20, 30. So these are the item need to display here. I think hope you all clear. And the time complexity, we need to discuss about the time complexity and space complexity. Time complexity means we need to end the n item, right? We need to print the n item. That means bigger of n is the uh, time complexity, because n times it need to iterate, and the space complexity is bigger of 1, because there is no need, because in this solution you can look at here, there is no recursive call, recursive storing, nothing is happening. So that is the reason it will take only constant amount memory space, that means bigger of 1. So this is the all idea regarding this linked list. The later videos we will discuss one by one. Yes. If you have any comment, let's comment below.